Welcome. This is for this literal equation section, and it's a challenge type of problem because it has an extra issue in it that some people will find interesting and maybe quite complicated. But there's a trick to doing it that makes it very possible to do. Well, our goal is to solve for x, but there's two x's in it. So we have to get to the point where we have x by itself. So somehow those two x's are going to have to be put together or cancel out, but then we won't have any x's, so I'm not sure that'll work. So I'm going to show you the way to do it. If you consider this a fun challenge or a possible good challenge to try, then do it yourself first. Pause the video and then come back to it and see if you can do it. And see if you then match what I'm going to be talking about. So I am going to attempt to get these x's somehow put together. And here's my way of doing it. Okay? I am going to bring this over to the side. So I'm going to subtract 2xy from both sides. So I have 7x minus 2xy minus 3 is equal to 0. I don't need that minus 3 there, so let's add it to both sides. 7x minus 2xy equals 3. Now, all I've done is just move things around. Nothing more than that. I've did the subtraction property of equality to bring 2xy to the other side as subtracting. And I did the addition property of equality to add 3 to both sides. And now I have it where I have the x's next to each other or together. What that means now, because both of these terms have an x, I can take out a common factor, a number that is common to both of them. And remember, what this is the opposite of the distributive property, or it can even be considered the distributive property. So now I have x times, or in parentheses, 7 minus 2y, close parentheses, equals 3. Now, at this point, you need to recognize something. Like, say you had x times w equals 3. If I wanted to solve for the x, all I would do is I'd divide both sides by the w, and I would have x equals 3 over w. And I would have solved for the x, and this would be the answer. You have to think of this thing as a single entity, sort of like the w. Okay, so you have to consider it's together. Because it's in parentheses, it's a single thing. It doesn't look like it. It's a single like term. It doesn't look like it because it has two separate terms in it, but because it's in parentheses, that makes it considered together. It makes it like combined. Okay, so that means what I can do is I can divide this by 7 minus 2y. And that means that this whole thing cancels out with that whole thing, and it brings it over here as 7 minus 2y. So I have a final answer that x is equal to 3 over 7 minus 2y. The fact that the variable y is in the denominator, there's nothing wrong with that. Okay? It seems like a simple little thing on the other side, but that's what x is equal to. The key to this is that I was able to get the x by itself by taking it out as a common factor. Or another way, it's the distributive property is what it is. It's just going backwards in the distributive property. That distributive property is so useful in so many ways. That's how you handle it when you have two variables, or you have a variable, but it's in there twice. You could put them together on the same side and take out the variable as a common factor if it's similar to this type of a problem here. I hope that helps with understanding this. Thank you for listening and watching.